Hi everyone, this is Vijayalakshmi from WinMaths. Today we are going to explain or discuss the questions on relations and functions on exercise 1.1. Here in that exercise we already discussed the first question, 4 questions already in our last video. Now continue the session. The in that questions exercise problems, first question, fifth one. Okay, that is relation are in a set A of human beings in a town at a particular time given by. Here there is a relation R is equals to x comma y such that x and y work at same place. Here in this question we have to concentrate on the place. Okay, that x and y are the two persons work at the same place. And now we check for the condition reflexive. Okay, in that reflexive condition we have taken as x comma x, because our reflexive definition says two elements both are same or one element that is itself holds the relation. One element itself holds the same relation, that is for every consider x comma x such that x and x are same persons work at the same place. Same persons work at same place, but here same place, the place doesn't change. Okay, therefore x comma x belongs to R. It is reflexive. Next, for second condition. Okay, for second condition, trust, that is symmetric. Here in this symmetric condition we have to consider two persons. Okay, we have to consider two persons, that is x and y are the two persons. X and y are work at same place. X and y are work at same place. Here place doesn't change. Again, that implies y and x are work at same place. Y and x work at same place. Then for third condition, transitive. For the transitive condition, consider xy. Consider x comma y. Okay, consider x comma y such that x and y work at same place. Okay, work at same place. Then y and z. Z is also another person. He also working at same place. Then y and z work at same place. Here x and y work at same place and y and z are work at same place. That implies x and z are also work at same place. Now consider for second one. Relation are such that x and y are live in same locality. Here the condition is same locality. Okay, now check for reflexive condition. Okay, for reflexive condition x comma x, okay, which is belongs to R, because x is a same person itself, he was live in the same locality. X and x are same person, x and x are same person live in or live in the same locality. Therefore, it is reflexive. Again, for checking the second condition, symmetric. Here, x and y. Here, x and y are two persons, okay, such that x and y live in the same locality. Live in same locality, that's all, or that implies y comma z, such that y and x live in the same locality. Hence, it is symmetric. That is, x comma y belongs to R and y comma x belongs to R, such that it is symmetric. Now, consider for third condition, transitive. Okay, third condition, transitive. Here, x and y are two persons, x and y are two persons live in the same locality. Consider another one person, y and z. That person should be a z. Y and z live in the same locality. That implies x comma z, such that x and z live in the same locality. Live in the same locality. Hence, it is transitive. That is, x comma y belongs to R and y comma z belongs to R. That implies y comma x comma y belongs to R and y comma z belongs to R. That implies x comma z belongs to R. Therefore, it is transitive. Therefore, it is transitive. Now, let's discuss the next problem. Here, consider the relation R is equals to x comma y such that x is exactly 7 centimeter taller than the y. Here, we have to notice the relation or condition, exactly 7 centimeter taller. Now, check for the condition, reflexive. First one, reflexive. Here, x is one person. Here, x is a one person. A person is not exactly 7 centimeter taller than him. Okay, when his height will be, for example, taking one boy and taking one example, boy, and his height becomes 145 centimeter. Now, for reflexive condition, every person not exactly same of height. Okay, here the condition is x is exactly 7 centimeter. No one can exactly 7 centimeter taller than himself. Okay, X is a person. He is not exactly 7 centimeter taller than himself. Therefore, x comma x not belongs to R. Therefore, it is not transitive. Hence, it is not reflexive. Again, for symmetric condition. Again for symmetric condition. Here, consider the two persons x comma y. X is exactly 7 centimeter taller than y. It means x is exactly 7 centimeter taller than y. It means x height becomes larger. Okay, whatever y's height, if y height becomes 130 centimeter, then x height will be 137 centimeter. Now, similarly, for y comma x, y is not exactly 7 centimeter taller than x, because y's height becomes 137 and 130 centimeter and x height becomes 137. Again, here x is the larger height. Okay, but when we take an y is, because y height already 130 centimeter. Now from this condition y becomes 144. It is not possible. Okay, therefore x comma y belongs to R, but y comma x not belongs to R. Again, check for transitive condition. Here x comma y such that x is exactly 7 centimeter taller than y, and y and z such that y is exactly 7 centimeter taller than z. By this condition, we have to take one example. That is, x height becomes 137, then y's height will be 130. We already consider in symmetric condition. Again, z. For z, y is exactly 7 centimeter taller than z. It means z becomes lesser than 7 centimeter, right? That is 123 centimeter. Now, that implies x and z such that x is not exactly 7 centimeter, exactly 7 centimeter taller than z, because compared to x and z height, compared to x and z height, it becomes difference will be 14 centimeter. Hence x is not exactly 7 centimeter taller than z. That is, x comma y belongs to R and y comma z belongs to R, but x comma z not belongs to R. Therefore, it is not transitive because it is not transitive condition. Okay, next we consider next question. A relation R is equals to x comma y such that x is wife of y. Here mainly the condition is x and y. Wife means must and should there is a husband and wife. Then it means one is male and another one is female. One is male and another one is female. Okay. Now for reflexive relation, here x comma x such that x is a wife of y means x become female and y becomes male. Okay, x is not itself a wife because x is a female but y becomes male. X is related to x means one is female and another one is male. It is not possible. X is not a wife itself. X is not a wife itself. So x comma y, x does not belongs to R. It is not reflexive. Again, for symmetric condition, here x comma y, x is wife of y. Okay, that implies y comma x. Y is not wife, he was a husband. Y is husband of x. That the relation not exist here. Therefore, x comma y belongs to R. X comma y belongs to R, but y comma x does not belongs to R. Okay. For transitive condition, x comma y such that x is wife of y, but condition y and z, y is not wife of z because he was a male person. But in our relation x is y is wife. Okay, it doesn't possible. Therefore, it is not transitive. It is not transitive. Not possible relation. Not possible. Okay. Again, for fifth one. Again, for now, a relation R is equals to x comma y such that x is father of y. Here check for condition reflexive. Okay, reflexive x comma x. X is not itself a father. X is not itself a father of x because x is a son, x is a father and y becomes son. Let a relation R is equals to x comma y such that x is father of y. Here first condition reflexive x comma x. X is not itself a father of y because x is father of y. It means x is a father and y becomes son. X is not itself a father of x. That is x comma x does not belongs to relation R. Therefore, it is not reflexive. Then for symmetric. here relation x comma y, x is father of y, but y is not father of x, because y becomes son. We already know the condition, y becomes son and x becomes father. Therefore, x comma y belongs to R such that y comma z, y comma x does not belongs to R. Therefore, it is not symmetric. It is not symmetric. Then, transitive condition. Here, x and y such that x is father of y and y comma z, y is a father of z, but comparing, that implies x comma z, x is not father of z because x is a grandparent. X is a grandparent of z. Therefore, x comma y belongs to R, y comma z belongs to R. That implies x comma z not belongs to R. Therefore, it is not transitive. It is not transitive. Okay, students, let's continue second questions in next session.